Good morning. Today we will be working on adding and subtracting rational expressions. This is Algebra 2, TEKS 2A.7F, which is determine the sum, difference, product, or quotient of rational expressions. Question number 1. So we have these two expressions that we're adding together. But in order to add expressions together, they have to have a common denominator. So we have to find our least common denominator. Well, on our denominator, we have an x plus 3, and we have an x minus 2. So my least common denominator would be actually putting both of those together. So whatever I'm missing is what I have to multiply by. So my first fraction is missing the x minus 2. And if I multiply on the denominator, I must also multiply on the numerator. My second fraction already has the x minus 2, but it's missing the x plus 3. And if I do it on the bottom, I must also multiply it on the top. By doing this, I have created a least common denominator. So my least common denominator is x plus 3 and x minus 2. Now on that first one, that 4 times x minus 2, I'm going to distribute into that, and I will have 4x minus 8. This is a plus sign, so luckily I don't have to change any signs, it's plus. I'm going to distribute on the second fraction, and I have 2x plus 6. Now to combine like terms. On my numerator, I have a 4x, and I have 2x. 4x plus 2x is 6x. Then I have negative 8 plus 6. Negative 8 plus 6 is negative 2. And my denominator is still x plus 3, x minus 2. Now we factor till we can factor no more. So my numerator has a greatest common factor. So I'm going to factor out a 2. So I'm going to put a 2 on the outside. And when I factor out a 2, I'm basically dividing both of these terms by 2. So 6x divided by 2 is going to be 3x. Negative 2 divided by 2 is negative 1. And I bring over my denominator. Since I have no common factors on the numerator and denominator, that is my final answer. But one thing we have to talk about is domain restrictions. In our original problem, we have an x plus 3 on the denominator and an x minus 2 on the denominator. These cannot be equal to 0. If they are equal to 0, this is a domain restriction since we cannot divide by 0. So one thing I have to remember to do is to take each of my denominators that have an x and set it equal to 0. Okay, so x cannot be negative 3. Move the 2 over. So I'm going to go ahead and put a semicolon. That's just the way I'm going to separate it. X cannot be equal to negative 3, and x cannot be equal to positive 2. Those domain restrictions are very important, especially when we get into solving. Those cannot be part of our solution. Okay, here's our next question. We look at our denominator, we see an x minus 3 and we see an x plus 1. My least common denominator is going to be x minus 3 and x plus 1. So on my left fraction, well, what is it missing? It's missing the x plus 1. So if I'm going to add it to the bottom, I also have to do it to the top. And I'm actually multiplying x minus 3 times x plus 1. My second fraction, I'm missing the x minus 3. If I'm multiplying by x minus 3 on the denominator, I must also multiply it on the numerator. So go ahead on the left side and distribute the 9. You have 9x plus 9. On the right side, distribute the 2x. You get plus 2x squared minus 6x. Now remember, we keep going until we can go no more. Let's go ahead and put this in order as we combine like terms. In order means I'm going to start with 2x squared. Then I have a 9x and a negative 6x. So 9x minus 6x is a positive 3x. And I'm left with a positive 9. My denominator stays the same. Now my numerator, I do have to check if it's factorable, and it is not factorable. There is no numbers that multiply to AC but add to B. So that's actually my answer, but we cannot forget my domain restriction. So take your denominators, the original denominators, and set them each equal to 0. So if x minus 3 equals 0, then x cannot equal positive 3 because you add 3 to both sides. On this one, if x plus 1 equals 0, subtract 1 from both sides. X cannot equal to negative 1. We have one more question to complete. Now, I have a trinomial on my left side. I need to see if it's factorable. And A is 1. So we're looking at factors of A times C, but they have to add up to 5. So which two numbers multiply to negative 24, but add to 5? Make a table if you have to, but I see that it's 8 and 3, because one of them has to be a negative. Remember that if this is a negative, one number has to be a negative. This sign tells me the bigger number has to be positive. So x plus 8, x minus 3 are my factors of that trinomial. So now, what are my different things on my denominator? What is my least common denominator? X minus 3 and x plus 8. My first fraction, it has both of those. So I actually do not have to multiply by anything. I just bring down the 12. The second fraction, I'm missing the x plus 8. So if I multiply the denominator, I must also multiply my numerator. Okay. Now distribute the positive 3. I get plus x plus 24. So I combine like terms on my numerator. I have 3x plus 36 over x minus 3x plus 8. Don't forget to keep going until you can factor no more. My numerator, it has a greatest common factor of 3. So I'm going to factor out a 3, which means I'm going to divide everything there by 3. I'm left with x plus 12. I bring over my denominator. Is there anything on the numerator and denominator that would divide by each other to equal 1? The answer is no. So that is my answer. Don't forget domain restrictions. Come back to your original equation and set them equal to 0. Now, because this x minus 3 is already over here, I don't need to do it 2 times, okay? So x minus 3 equals 0. That means x cannot be equal to a positive 3, because 3 minus 3 would be 0. When I set this equal to 0, I move this over, so subtract 8 from both sides. X equals 8 would give me a division by 0, which remember we're not allowed. So X cannot equal 3, and X cannot equal negative 8. Hopefully this video helped you with adding these rational expressions. And if you want more videos, go ahead and subscribe to my channel, and I will be posting more. Have a great day.